Earlier this morning, ULA launched the second Vulcan, carrying mainly an inert payload, a part of the vehicle's second certification flight. However, about 40 seconds into the mission, one of the solid rocket boosters experienced an anomaly. This led to an asymmetric exhaust plume, reduced thrust, and a change in the flight profile regarding SRB burnout and jettison in order to compensate. Fortunately, ULA is reporting a successful insertion despite the anomaly. Here I'll go more in depth into the launch, comments from CEO Tori Bruno, what to expect, and more. This morning at 7:25 Eastern Time, United Launch Alliance's Vulcan Centaur lifted off for the second time ever. The vehicle has multiple configurations, including no SRBs, 2, 4, and 6. On this specific flight, the vehicle was in the 2 solid rocket booster configuration with 1 on either side. At engine ignition, you can see both the 2 BE-4 engines along with the SRBs ignite as expected, followed by liftoff. From here, the vehicle cleared the tower and began gaining altitude. Only 20 seconds in, Mission Control stated that the BE-4s were performing as expected, and that all temperatures and pressures were looking good. That was until T plus 38 seconds when you can see the SRB anomaly take place. Specifically, looking at the bottom of the SRB, there was a relatively large shower of sparks which is thought to have come from the engine nozzle. Seconds later, when the camera changes, you can now see that specific booster's thrust plume is asymmetric to the other. At T plus 54 seconds, an additional set of sparks fly off the SRB. From here, the mission continues, but not exactly as originally planned. At T plus 1 minute and 27 seconds, Mission Control calls out that they have indication of SRB burnout in preparation for jettison. Looking at the flight profile, you can see that the SRB jettison is set to happen at T plus 1 minute and 49 seconds. As they approach T plus 2 minutes, both SRBs are still producing some thrust and obviously not jettisoned. You eventually see one of the SRBs finally burn out first, followed by the second soon after. At that point, right at T plus 2 minutes and 10 seconds, the 2 SRBs jettison from the booster. Over the next 3 minutes, the 2 BE-4 engines continue to fire with an original booster engine cutoff scheduled to happen at T plus 4 minutes and 59 seconds. In reality, this mission milestone wouldn't actually happen until around T plus 5 minutes and 7 seconds. In other words, in order to compensate for the loss in thrust due to the SRB anomaly, multiple mission milestones were extended in order to make up for the difference. The booster then separated from the upper stage, and they called out that the booster performance was within expectations. Eventually, ULA tweeted saying, United Launch Alliance ushers in a new era of space capabilities with the successful launch of its second certification flight, CERT-2, of the next-generation Vulcan rocket, and reach an orbital bullseye insertion. ULA CEO Tori Bruno also said, Bullseye chart coming. I imagine some of you are especially curious. Orbital insertion was perfect. While successful, the first thought that came to mind was whether or not they would have had the same fortunate outcome had there been a real payload on the vehicle rather than a dummy payload. Originally, the second Vulcan launch was actually set to be the maiden flight of Sierra Space's Dream Chaser Tenacity. However, Tenacity needed more time, and ULA was eager to get Vulcan certified, so they made the decision to just launch a dummy payload instead. Within the fairings were 2 payloads, one of which was an inert steel structure that matches the mass, stiffness, and other dynamics of the Peregrine lunar lander. The second payload was a set of upper stage advanced performance and technology experiments. On Twitter, someone made a comment saying that had Dream Chaser been on board, Vulcan might not have made the insertion. Tori Bruno responded by saying, incorrect. Rocket performed as designed, compensating for the reduced thrust from SRM-1. Propellant consumption was within baselines, always present reserves, and margins, based on payload mass, were unaffected. Tori Bruno was also quoted saying, all missions have propellant reserved. We add to that additional propellant margins based on the mass and the configuration of the rocket. Because this was compensated for within reserves, the anomaly was invisible to the rocket, he said. Looking back at the footage, he mentioned, yes, it looks dramatic, like all things on a rocket. But it's just the release of the nozzle. No explosions occurred. On any given mission, Vulcan integrates up to 6 Northrop Grumman graphite epoxy motor or GEM-63XL solid rocket boosters, SRBs. These boosters are constructed out of a graphite epoxy composite with a throttle profile designed into the propellant grain. These boosters are around 72 feet or 22 meters tall and produce a peak vacuum thrust of 459,600 pounds. What'll be interesting to see is how this affects the vehicle's certification. This process involves working with the US Space Force to eventually carry national security payloads starting later this year. The purpose of this mission was to demonstrate Vulcan's high-energy rocket architecture by achieving an Earth escape trajectory and placing the Centaur 5 with an inert, non-deployable payload into deep space where it will orbit the Sun for the rest of time. While they were successful, obviously the anomaly could end up causing some slight delays at the least until the root cause is found and fixed. Leading up to the launch, both graphite epoxy motor 63XL solid rocket boosters were added to the sides of the first stage on August 13th and August 14th. Here, each motor is filled with over 100,000 pounds, or around 45,000 kilograms of aluminized solid propellant. Together, the methane-fueled main engines and SRBs provide the 2 million pounds or 8.9 kilonewtons of thrust generated at liftoff to power Vulcan off the launch pad. In a statement before the launch, ULA said, "This is the second of 2 flight tests required for ULA's certification process with the US Space Force. ULA has worked in close partnership with the Space Force throughout the design, development, testing, and production of the next-generation rocket for assured access to space. The Space Force selected Vulcan as the #1 offer and best value choice in the Phase 2 National Security Space Launch or NSSL competition. Vulcan incorporates the best attributes of the Atlas and Delta Heritage rocket families and introduces innovative technologies and streamlined processes, creating one launch solution that meets the demanding requirements for launching critical national security missions to the full spectrum of orbits," they said. While the Anomaly is not ideal, they seem to be confident in the vehicle's performance and future. Earlier this year in January was the first flight of the vehicle carrying the Peregrine lunar lander. That mission ended up being successful, at least on the launch side of things, and marked a good start for the Vulcan rocket. A few days ago, when talking about the mission, Bruno said, "I'm supremely confident, having had a very clean Cert 1 mission. It was the cleanest first launch I've ever had. So, as I come up on Cert 2, I'm pretty darn confident I'm going to have a good day on Friday, knock on wood." It'll be interesting to see the effect this has, if any, on some of the upcoming missions. Even though Dream Chaser missed its first ride on this flight, they're still set to lift off on a Vulcan sometime next year. Even before then, assuming the Space Force is satisfied with how the mission went, there are multiple government launches scheduled both in November and even December. These missions feature a geostationary orbit destination and the use of 4 solid rocket boosters rather than just 2. On the bright side, other than the SRB Anomaly, the rockets seem to perform very well. This was only the second time BE-4 engines have actually flown, with the first being the Cert 1 mission. They were reported to have done well and helped compensate for the lost thrust in the booster. Days before launching, integrated testing and a complete electrical checkout of the combined rocket and payload were completed, while final readiness reviews and closeout activities were performed in preparation for rollout of the rocket. They also conducted a full day of launch tests to ensure the new rocket, pad systems, and launch team were ready for the second Vulcan mission. The wet dress rehearsal exercises the hardware, procedures, and the people to reduce risk of a delay on launch day. That rehearsal follows a tightly scripted sequence by rolling the Vulcan from the vertical integration facility to SLC-41 and performing the entire countdown operation to fuel the rocket with cryogenic propellant. The final phase of the countdown pressurizes the rocket, arms various systems, and transitions the vehicle to internal power. The count finishes just prior to ignition time. In the future, we should hear more about exactly what happened and how it affects some of Vulcan's future missions and dates. This morning, Vulcan lifted off for a second time but experienced an anomaly with one of its solid rocket boosters. This created reduced thrust in an asymmetric exhaust plume and required additional burn time to compensate. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.